Hello everyone, I'm so excited for this lesson. This is lesson number 10, big number. And this for your exam, for your PMP and PMI-ACP exam, this topic is extremely important. So this chapter, this lesson is extremely important. What are we going to learn in this one? Let's quickly take a look at the learning objectives, what the topics that we are going to cover. We are going to talk about agile metrics, velocity charts, burn-up charts, burn-down charts, lead time, cycle time, cumulative flow diagrams, and escape defects. So let's jump right in and start with velocity charts. Before that, just a little point about the metrics, understanding why metrics is important. In any project, it is very important to see how the work is progressing and how the team is performing. So agile metrics, while it's far more flexible than the metrics that you have in a predictive waterfall style of a project, but still there are metrics that show you how the project is performing, how the team is doing, and these ones are the most important and commonly used ones. Okay, so first we'll talk about velocity charts. Now, velocity, what does the word mean? The word means speed of something. So, velocity is the rate at which the team delivers the work. Let me explain it to you by this chart that you have here. If you look here, it's a little small, but this is sprint one. These are sprint numbers. And the figures, the digits that you're seeing here, these are the number of story points completed by the team in each sprint. Quick recap, story points are the points assigned by the team to every story by using story point estimation techniques, relative sizing as we call it. We covered it in lesson number 9. So if you've not done that, if you've not gone through that lesson, you can check in lesson number 9. So the story points that the team covers, finishes, completes in each sprint is plotted here. Now, how will you read this chart? The team velocity is the rate at which team delivers the work. Now you're seeing 5 sprints here. If we do a sum total of these story points, 45, 50, 52, 52, 48, it will come to an average of 50 story points. So you have 5 sprints, you'll do a total, it'll come to 50 story points per sprint. So that is the average rate. Okay, so what did we do? We looked at the total number of story points covered in each sprint. Then we divided it by the number of sprints. That gives us an idea of, on an average, how many story points the team completes in each sprint. Now, there are two uses of this information. Metrics is for some use, right? What do we want to check? First, we know how, at which rate the team is progressing, it's good or bad. The second one is a predictive purpose. So say, for example, there are a total of 500 story points in a project, okay, to come or feature. To complete a feature, the team needs to complete 500 story points. Now we know that the velocity of the team is 50 story points per sprint. So how many sprints will the team need to complete that 500 story points? That calculation is simple. The velocity is 50. The team needs to complete 500 story points. So the team will need 10 more sprints. So 500 divided by 50, 10 more sprints to complete. So this way, agile teams can predict when the work will be completed. Velocity, to gauge velocity, to understand what the velocity is, it usually takes 2 to 3 sprints for the team to arrive at a conclusion that on an average, these many story points we are completing in each and every sprint. Okay, so this is about velocity charts. Now, extremely important, it is impossible that your exam will not have a question on burn down charts. Burn up and burn down charts. We call them burn charts. Let me just explain it to you with the help of this chart here. You're seeing two data points here. The blue line is the total number of items that the or total number of works. Usually it is expressed in story points or features that say, let's say story points for now. 100 story points is the total expected product backlog that the team needs to complete. So this line shows total. Now, very interesting. See, around iteration 5, between 5 and 6, this is going up. That means more stories are added to the product backlog, which has increased your product backlog or your story point total to 120, which means there has been a scope creep. Scope creep is when more items are added to scope, and agile is flexible in terms of change management. So maybe more story points are added, more work is added to the project. That's why this hike you're seeing. Now, burn up chart shows how much work the team has completed. Remember it like this: up, upside, that means progress, how much work the team has completed. Sorry. Burndown charts show how much work is left. So up is completed, down is left. So here you're seeing that in iteration 1, team completed 6 story points, and till iteration 8, the team has completed 97 story points. That means there is an upward trend. The team is performing well, and there is very little work that is left. Quickly read it here. What does a burn-up chart show? A burn-up chart is a visual tool that tracks progress in an agile project. It shows total work here, completed work here, and a trend line that predicts when the project will be completed. All right. Now let's talk about burn-down chart. Opposite of burn-up chart. Burn-down chart shows how many story points are left. Okay, so this is story points remaining, how many story points are remaining in each day or in iteration. Sprint also you can log here. So a burn down chart is a key agile tool that tracks the remaining work over time, helping teams visualize progress towards completion. How do you plot it? On x-axis you have the time period. It can be days or it can be iteration sprints. Y is the total amount of remaining work, and this trend line shows how they are progressing. Now, how will this come? They will not, in exam they will not ask you to plot it. They will not give you the chart. Mostly they'll give you a verbal question which talks about a problem, and it will be around how will you know what work is left, and how will you see progress, how will you assess how team is performing, and the answer will be burn up or burn down charts. All right, what do we have next? Lead time and cycle time, very important, because I have seen people getting confused in these two terms. Okay, so the first thing that you need to remember is cycle time is a subset of lead time, which means lead time is bigger than cycle time. Now what you have here is a Kanban board. All of you must be aware of a Kanban board, which is a visual tool that shows how work is progressing from start to finish. There can be different categories, columns in a Kanban board: backlog, in progress, done. These are the common categories. What you're seeing here is ready. Ready means it's ready to start work on, which is your product backlog. Developing unit testing is happening for these stories. Development done is for these stories, and testing is happening here, and these are done. Now, let's look at it to understand what is lead time and what is cycle time. The moment an item, a task, a feature is placed into this board or in product backlog, from that minute to, from that day to the time it's delivered, it's done, that total time is lead time. However, there can be items lying in your product backlogs or sprint backlog without team actually picking them for development. So there is a waiting time. Now the moment team picks it up, from that time to finish time is your cycle time, the actual work, when the actual work is being done. Lead time is the total time taken for a work item to move through the entire process from the time it was placed in the backlog. Okay, from the time the request was made to completion. That entire time is your lead time. It includes waiting time, review time, and actual execution time. Cycle time is the time taken for a work item to move through a specific part of the process. What we are trying to simply say is that when the team picks it up for work, when the actual execution is happening to finish, that is your cycle time. It is a subset of lead time. Okay, now I have put some more points for better understanding. For comparison, lead time is the total time from request to completion. Cycle time is time from work start to completion. Okay, lead time includes wait time plus active work. It includes only active work. Now when you look at lead time, which is very, if it is very high, it shows that there are bottlenecks. Work is not being picked from one task to another. It's not progressing. So higher lead time is not a good thing. Okay, cycle time shows efficiency, how fast the team is able to finish the work. Okay. A little bit more in the same topic, another term that keeps coming is throughput, and people get confused. Throughput is the number of items. Now, it can be tasks, it can be features, it can be stories. Number of items that the team has completed in a given time. How do you calculate cycle time? Is your work in progress items if the team is working on 10 stories at the same time. Okay, 10 tasks are in progress and the team completes 2 tasks per day. So what is throughput? Throughput is the amount of time, sorry, the number of tasks that the team is completing in an amount of time, which is 2. So team is completing 2 stories per day. There are 10 stories which are currently in progress. So what is the cycle time? Cycle time is 5 days per task, which means so team is completing 10 tasks. Uh, uh, Team is doing 10 tasks at the same time, and it is taking two, it is completing 2 tasks per day. Okay, so cycle time is 5 days per task. Team is taking 5 days in completing one task. Okay, that is your throughput. A little bit more about it. Velocity and throughput comparison, because people sometimes get confused. Velocity is work completed per sprint. Average shows a trend. And what is the unit? Story points. In throughput, completed work items in a given point of time. What is the number of stories that the team has completed in any, not necessarily per sprint, maybe per day. But it main difference is that it calculates number of stories. This is calculating story points. This is calculating number of stories. Throughput is mainly used in Kanban and also in Scrum. Velocity is a Scrum term. Now, velocity helps with sprint planning and forecasting because we know the average rate at which the team completes the work, so we can predict how much time the team will take. Throughput is mainly for efficiency. How efficient is your team? How efficient is the workflow? It is also used in VSM, which is value stream mapping and improving efficiency, and in lean projects. Okay. Now we will talk about cumulative flow diagrams. As you're seeing, this is an area chart. Okay. Now it's a little small here, but there are 4 sections here. This is ready, which means your backlog. This is in progress, which is development is going on. This is testing, and this is done. Now you see that this part is very big. Why is it big? This means that items are not moving from development to testing, and testing is very small. Here the work items are less, which shows the bottleneck. Bottleneck is any part of the process where the work is compiling, from where it is not moving ahead. That is your problem area. So these charts show you how the work is moving and what is the problem area. Now, if there are steady bands, similar size, that means there is a consistent throughput. Everything is fine. Widening bands, like here, development is widening. That means that the work is getting stuck here. Work is getting accumulated here. So you need to look into it and see what the problem is. Then narrowing bands, faster progress. So testing is getting done faster, but your development is the problem. So these are your cumulative flow diagrams. The question in your exam can be, you look at a diagram and see how the work, where the bottleneck is, or there can be a verbal question about it. Okay. Last point, which is defects, and then what is escaped defects. No matter how many times your team has done the same project, or if it is a new project, defects can happen. It's a very human thing. Okay. So, first of all, the awareness that the team needs to have that the defects can happen, but it's a quality measure to keep them in check. What do I mean by that? Is that the team needs to do continuous testing to find them early. It's a quality metrics. The longer the defect remains unfixed and undetected, more difficult it becomes to fix it later. Cost of quality, it's a concept that we learn in during waterfall style project management, also in Lean Six Sigma, which means that the more time a defect spent, the later it's detected in the process, the more expensive it becomes to fix it. And escaped defects are defects that made to the customer. Okay, so the team was not able to detect them and they made to the customer, which not only affects your customer satisfaction, but it also is harder to fix it because it is already in production system, and then it becomes difficult for the team to rework on it. So basically, defects are bad, more rework, there are complex fixes, the more time it spends in the system, there is a broader impact and higher cost. Okay, so the point here is that the team needs to make that quality approach inbuilt in their project so defects are detected early. So that's all that you need to know in agile metrics, and we will meet in the next chapter. Thank you.